Thanks for having me. It's a great opportunity to share my work, and I appreciate being here. Thanks for the introduction. If you're interested in these slides, you can find them at my website, and they'll be under presentations and under talks. All right, so I don't usually label myself with labels particularly, but if I were to sum up my research and what I'm going to sort of describe today in terms of my work, I would call myself a research education innovator. And I think the reason this happened, which I'll explain a little bit, is because I'm a very curious and anxious person, and I'm also a bit of a perfectionist. I'll explain how those play in. And I'm focused on the big picture. And so that kind of led me to think about why we actually do research the way that we do, and is there potentially a better way? So a little bit about how I got here. So I was an informatics researcher initially. My background is in biomedical sciences. As you heard, I used to study psychiatric genomics, particularly focusing on gene regulation and non-coding RNA, developing methods to try to quantify and profile those RNAs, and also merging data from imaging and genetics together. And so I had experience, I have experience with wet bench and dry bench research, and I think that gives me a sort of broader perspective on the research landscape and the experience that some people have. So my postdoc felt a little bit like this, and I imagine that's the experience for lots of people. It was a bit of a frenzy. It was really fun, but also a lot of work. And something I noticed a lot was that I very often felt very torn. And so this might have to do with my perfectionism, but I kept wanting to learn more domain-specific knowledge, do my work, but also wanted to train myself to do it better. And really apply those practical skills that I needed to do my day-to-day work in the best way possible. But I didn't ever feel like there was a lot of time for this extra training. And my anxiety made me want to go faster. And so sometimes I felt inner conflict about that. And so this made me curious that maybe there's a better way, and how can we help other people who also have this experience? And so that's part of why I co-founded the LIBR Stats Club with some of my peers. And I wrote here that, sometimes your side projects become a big part of your career, so watch out. In my case, I feel like it was a good thing. So I learned some lessons from that and through my time. One is you can work smarter, or you can also train smarter. So spending an extra hour today can actually save you countless hours later. And so sometimes it's worth it, even though it feels like you're wasting time. And we can always get better. There's always ways to become more rigorous, more reproducible, more efficient, more ethically conscious, use newer, exciting methods, be more flexible with different data sources, so we can always improve. But the trouble is, often the way this plays out in research is there's a lot of trainees and researchers who end up self-training, and that ends up in a lot of holes in their knowledge. And the problem is that we don't know what we don't know, so we don't know if some of those holes are really critical and we need to fill them. And so we really need expert guidance telling us what we should be training ourselves on. And so experts should help make training materials. And we also need materials to be accessible. Often training materials are written in a context or field context specific way, and that can make them really inaccessible to lots of audiences that could really benefit. And it's not just me. That's another major lesson that I learned. I see this everywhere, and the further I get in my career, I just keep learning this lesson over and over. Everyone could use some help. And so even the brightest students, they still don't know how to train themselves on all of the supportive skills that they could possibly need for their research. PIs have limited time to teach their trainees, and they also have limited time to train themselves. And research is a continual process of learning. And so here's some specific examples that I think kind of ingrain this idea. Oops. No. Let me just get back to slideshow. There we go. Okay, so during the pandemic, I'm sure you're all aware, at the beginning of the pandemic, everyone was very excited about contributing because we were all very concerned and wanted to be helpful. But many of us noticed that a lot of people who wanted to be involved didn't have the skills to work with difficult data as flexibly as they'd like to. So, importing and wrangling data from gnarly PDFs and doing that reproducibly, that's a challenge. Importing data from various websites quickly, that can be a challenge. So that was something that I observed. Another example is, we're always creating new methods for omics and imaging. And so researchers want to take advantage of those methods. And we really want to support them to do that to the best of their abilities, whether that's on their own or through collaborations. We want to support that. And then also another more recent sort of surge in the research field is that people were really interested in asking more questions about diversity and IDARE and how to work with populations that have been overlooked. But unfortunately, some of that was done in a harmful way where people weren't really prepared to do that appropriately. And so, we want to help researchers do that kind of work. And so we want to help them to do that in the most responsive and responsible way. And so the overall problem is researchers want to maximize their efforts, but they sometimes don't always know how. And so we have this self-directed training that can lead to polls. We have many graduate programs that unfortunately sometimes lack exposure to comprehensive education. And research just always requires continual learning. So how can we provide education that would give a little bit more context to the skills that researchers need throughout their career? So a possible solution is to provide more training opportunities that would empower learners with those more complete exposures to skills that they do need. And some ways to do that is to, instead of having self-directed training, we have more expert-directed training. We have places where people can find out what skills they actually need to know. We can have more comprehensive graduate programs. We can have more sustained support for researchers throughout their careers so that they can find resources as they're doing their research. And we should really create resources that aren't recreating the wheel over and over again, but instead share among ourselves resources that are designed by experts, both in terms of the domain topic and also in terms of education and instruction. So for me, I'm biased because I'm in the data science lab, but for me, it all comes kind of down to data science. And so I'm going to provide my definition of data science, which I know varies a lot. And so I'm just going to get mine and what I'm working with for this presentation, which is basically everything surrounding working with data to extract meaningful information and also to utilize or communicate that information. And so data science is really multifaceted to me and in this way. And so, it encompasses both hard and soft skills. So of course we have statistics that we're all really interested in that we all love and care about. But there's also elements of computer science and ethics, scientific communication, data security, data cleaning, data wrangling, etc. And so we're trying, I was of the mindset of, how can we innovate new ways to make education more useful? So if we contextualize and give more challenging and realistic examples, then that might allow learners to have a more realistic perspective on how they would actually apply what they learn. if we give more active experiences, then that can also improve a more comprehensive understanding. And again, providing resources for those who are continually actively doing research, so that we can continue to support people. So this is sort of my mindset. And then I already knew about the data science lab at Hopkins, but then ended up having more involvement myself, where the mission is to enhance data science thinking everywhere and make data science more accessible. And you can find more about it at the website here if you're not familiar. And so at the time, I saw Jeff Leake, who I know many of you are familiar with, give his tenure talk at Hopkins, and I thought that it was really brilliant. So he was describing this program now called Data Trail, which aims to equip young adults from underserved communities in Baltimore with skills to work in the data science workforce. And I thought that was a really unique and interesting way to work with data science and try to make a difference. And so I wanted to be involved in the lab. And luckily I got to. And the JHU Data Science Lab has a pretty broad reach. So we create MOOCs, which have collectively reached over 8 million learners, so massive online courses. But also do lots of initiatives that work with high school students, high school graduates, like I just referred to, undergrads, grads, postdocs, researchers, clinicians, and we work with students from various departments and fields, as well as lay audiences. And so while I was there, I got to work on lots of really interesting projects. I got to teach some more traditional courses. I did some short courses for the University of Washington as well, but also some projects that I'll be talking about today. Just wanted to shout out GDSEN is an interesting thing that we've also done, just working with communities, community colleges and schools that support marginalized populations. Created a MOOC about tidyverse, and I'll be talking about these 3 projects: the open case studies, ITN, and a Baltimore community data science course. And so I'm now at the Fred Hutch. I'm still doing those projects, though, at the Fred Hutch. I still also teach it at Hopkins. And at Fred Hutch, we have a pretty similar mission. We're coordinating data science activities, building community, making data easier to use, creating value for Fred Hutch data scientists, and working with partnerships in philanthropy and infrastructure to really support the scientists at Fred Hutch, but also extending outwards as well. And so at Fred Hutch, we also serve a really broad spectrum of people. We're still creating MOOCs. We're still helping people from the beginning to more advanced parts of the data science journey. And so what do we actually do? So we support informatics research, whether that's genomics, public health, imaging, or clinical data. We support research practices that improve reproducibility. We help with workflows, data management, taking advantage of resources like cloud computing. We support data ethics, particularly when it comes to sovereignty and data sharing. We support training for programming skills in terms of data processing and developing software. And finally, most importantly, we're really trying to grow in our research of pedagogy and also meta research, which is the research on research. So why do we do research the way that we do, and how can we improve? And one of our major values that we had at Hopkins and still have at Hutch as well is that democratizing education material really holds the power to improve diversity in science and medicine. So that's something that is really important to us. So challenges, of course, that's involved in this is that most learners have limited time. Some learners are extremely intimidated by certain topics like computer science. Again, most learners don't realize what they actually need to know and don't necessarily know. Many skills take time and practice, and some skills are really learned through the experience of application. And so we've kept these things in mind, and this is sort of my education philosophy for research, that encouraging contextualized training materials and experiences can be really helpful. Providing resources that are open source for broader use allows other people to use them, to modify them, to collaborate on them. So we're always open for feedback from the learners and from others to make our materials as good as possible. We like to modularize our training material so that people can pick and choose and use whatever they need to or don't need to. Create resources that help individuals while they're actually working. So thinking of the mindset of not just a learner who takes the course and then moves on, but maybe refers back to the material. Equipping researchers and trainees with this broader skill set and this consciousness to really think about the implications of their work. And finally, something that's really fun for us is utilizing technology to assist in the education process. Okay, so given all that, I'm going to describe 3 initiatives, those projects that I pointed out earlier. I'll talk about open case studies, which is basically this archive of experiential data analysis guides. I'll talk about the Baltimore Community Data Science course, which is having students work with community-based organizations. And then I'll talk about ITN, which is a resource for cancer informatics. All right, starting with open case studies, you can find more about it at opencasestudies.org. And so this was a project that was an idea of Stephanie Hicks, and I collaborated with her to create these case studies. And the overall idea here was that students needed to be empowered with more flexibility to use unusual and difficult data. We wanted students to be more efficient, to work with multiple files simultaneously. We wanted them to be more reproducible in their analyses so that other people could take their code and easily reuse it. And we wanted students to be able to more effectively communicate their results, whether that be through visualizations or otherwise, and really take those skills and apply them on new data. And so a possible solution for this was this idea of this archive of complete experiential guides that went through a data analysis from start to finish. And so we wanted to cover relevant and timely problems. We wanted them to be easily navigated so that people could choose what aspect of the data analysis was useful to them. We wanted them to be vetted by experts and easy to share. And so the idea with these is that they could be used by instructors and students both inside the classroom as well as by students and independent learners outside the classroom. So you can think of it as being directly used for instruction or as a supplement. And that these could be used by a variety of different types of learners in a variety of different fields. And so this is the team that worked on this. Again, Stephanie Hicks, and as well as some other colleagues at Hopkins, and some wonderful students that also helped. So this was funded by the Bloomberg American Health Initiative as a high impact project. And we created 10/11 public health focused case studies. You can see a different view of the case studies at this website where some actual web developers created this instead of our website. And I think it's a pretty interesting take as well. But basically there's 5 major topics that the Bloomberg American Health Initiative was focused on at the time. And so these include obesity in the food system, environmental challenges, addiction and overdose, violence, and adolescent health. And we created 2 case studies for each of these topics. And we tried to make each case study pretty diverse so that we could put as much information in each of them across the collection so that learners could pick and choose whatever skills they might need. And so we covered a variety of different question types, looking at things over time, comparing groups over time, comparing paired groups, etc. Using lots of different data sources, from simple CSVs to APIs, surveys with code books, multiple files, and then all sorts of wrangling methods, from extracting data from PDFs, joining, filtering, working with text data, doing really repetitive processes in more efficient ways. We also covered as much as we could about data visualizations, different styles of visualizations, why you would do those or not do those for different contexts, and more complicated specific details of that, whether that's, adding error bars, making them interactive, combining multiple plots, creating dashboards, and then of course covered a variety of statistical methods, as well as some machine learning. And then we got each case study vetted by experts. So we had public health experts, a team devoted to the various topics that we were working on, and also an external review committee to look at the case studies for the data science and statistical aspects. Had a great team. And so this is kind of what they look like, in case you're interested. They all start out with the dessert first. So it's got this, enticing image of what you might learn in the case study. It has this easy to navigate table of contents. These were created before Quarto, so they might look a little different than you might expect if we were to use Quarto. But the idea is that you could switch to whatever section you wanted to use. And each case study is motivated by a recent study or review, so that a report, so that there's greater context in case people are interested in that, and we provide a lot of background information. We're very clear about the main questions and the objectives. In this case, we parsed data science and statistics, although kind of consider them together, but just so it made it simpler for people to find the various things that they might be interested in learning. And then I received some funding to take this project further and make it even more accessible, more generalizable, more engaging, and do some assessments of it. If you're really interested, there's a thesis all about it. We also created a guide to help new users. There's some example use cases of people who have actually used them in courses, by Shannon Ellis, Jeff Leake, and Roger Ping. Some information about how to modify a case study, how to create a new case study, and guidance on how to contribute if you're interested. And so our guide looks something like this. And if you're really interested in PDF versions, which sometimes people are, there's also that available. But we made it easier to search for case studies. So we created a tool for that. So people could find a case study, for example, that uses forecats. We also made it easier to translate case studies to different languages. And we created a package to allow people to load the data more easily directly into R for various sections of the case study to make the modular use of the case study a little bit easier. And if any of you have instructed data science or stats courses, you probably know that this can be, for introductory levels, one of the most challenging parts. And so the old method, people had to find our GitHub organization, find the correct repository, download the data, put it on their personal computer, and figure out where it is and move it to the right working directory. And so it's much simpler now, just in their environment, they can use the package. And we also worked on making them more engaging by adding interactive questions, both multiple choice and also coding questions that have hints and feedback. And so we've done some surveys, which we keep getting more responses. Takes a slow trickle, but generally speaking, for self-learners, we see that people are generally interested in recommending case studies to others. We see a similar response for educators as well, and for students. And students are also generally interested in referring back to the case studies in the future, which I think is a really nice use of the case studies. And some qualitative data, made some nice responses from people who really appreciated them. But we want to do more analysis of the survey data, more analysis of actually using the case studies in courses and comparing that to other methods. And we have a manuscript under review that's on archive if you're interested. All right. Moving on to the Baltimore Community Data Science course, or BCDS. So this was a sort of passion project between Ava Hoffman, Michael Rosenblum, and myself. If you're interested in more about the course, there's also the website here. So this was done in partnership with SOURCE, which is the Community Engagement and Service Learning Center at Hopkins, which is really focused on helping people engage with the community appropriately. And that engagement should focus on social change, authentic relationships, and redistributing power. You can find out more about them here as well. The rationale was that data science should be performed with intention and mindfulness, while critically reflecting on our position in society and how that might influence our work. And so the philosophy was that students would work in groups, partnering with community-based organizations to help them address their data science needs or data-related needs. Ultimately, they would create some sort of data product that would have an immediate benefit, but also create infrastructure and education materials to help the CBOs take their own data-related goals further on their own, so empowering them with that. And changing the way that students approach work so that they would appreciate broader perspectives and reflect on their impact. And so students would really get quite a few benefits from this. They get to contribute to a meaningful project. They get to create some sort of data science product that they could put on their CV. They'd have hands-on experience in a context that's pretty different from typical classes. They'd have more training on topics in data science and data ethics, and they would learn more about the context of Hopkins in Baltimore, the history of that, and how that might impact their work, and thinking about designing things in a sustainable way. So students actually get exposure to lots of skills. They get exposure to skills. We do a lot of training for critical reflection, critical service learning, contextualization, product time management, collaborative work. They work in teams. They have to work with the CBO's organization. We basically let them lead all of that, communicating with each other and the organization, creating documentation and training material, and actually training the CBO, as well as sometimes the youth that are involved with those programs, thinking about data privacy and ethics, and data security, as well as problem solving. And then a lot of hard skills like text extraction, sentiment analysis, social media data analysis, creating Shiny apps, making lots of data visualizations, dashboards, interactive plots, working with GIS and R mostly, using version control, thinking about sustainability and design of software, reproducibility, and documentation. And so we worked with 3 organizations. We've done this class once and we're doing it again. And each instructor kind of led a project. So I worked with Heart Smiles, which is a CBO focused on leadership opportunities for underserved youth. Ava Hoffman worked with the No Boundaries Coalition to work with survey data to create a new narrative on gun violence. And Michael Rosenblum worked with the Baltimore Transit Equity Coalition to advocate equitable access to public transit. So this is a 16-week class, and we focused a lot in the beginning on preparing the students to work with the CBOs. And then the arrows here represent just going back to the CBO regularly to make sure that we're on the same page and really doing what they feel will actually be helpful to them. I'm not going to spend a lot of time describing what we did with each organization, but you're welcome to find this on my slides later if you're interested. But we created a variety of data science products. And so there's a lot of considerations and challenges that we observe through that, which is that you have to take time with the CBO to really identify the data needs. It requires a lot of upfront work, and it takes time to get the data from the CBO. There's a lot of special consideration that needs to go for data privacy and security, because sometimes organizations aren't familiar with those practices. You have to adjust and adapt dynamically. Training the students to really understand that the CBO's needs come first and that we need to consider their time and effort was a challenge for some of the students. And that, we weren't going to just make the coolest data science product that we could. It needed to be something that would be of use and sustainable for the CBO, which was a very different mindset for the students. And, it's also a dynamic and evolving problem for them to work on. So something that really warmed my heart reading some of the surveys that the students took, they said, this class has broadened my academic perspective in spades. I've done more reflection in this class than I've probably done in my entire academic career to date. So I think that really shows how we're not doing a lot of this in other courses for some of these students. We had students from a variety of disciplines. We had bioengineering, we had biostatistics, and public health. So it's a really fun class. So we want to do more evaluation of the long-term impact of these courses on students and also the CBOs, create more resources on the lessons learned to help others, and ideally expand this project if it seems useful. And then I'm going to go over the last initiative, the ITCR Training Network, or ITN. So ITN stands for ITCR Training Network. The idea is to catalyze informatics research through training opportunities. And you can find out more about this project at itcrtraining.org. So ITCR stands for Informatics Technology for Cancer Research, which is a program that's part of the NCI. And so what we're really doing here is trying to close a large gap that we've seen between people that create scientific software and the users, particularly if they're users that maybe aren't as familiar with using computational tools. And so we're trying to tackle that from both sides. So to improve the tool usability and also improve user preparedness for those tools. And so our ways of doing that is, enhance the usability of these tools, improve practices for informatics work in general in terms of fundamentals, and just raise awareness and access for these resources. So we're doing that in several ways. One is to make an archive of courses about informatics for both of these audiences, to make infrastructure and tools that would help ourselves and others create courses, to provide live education opportunities like workshops, and also enhance community engagement in cancer research. So this is our team. You might see some familiar faces here as well, including Howard. And our main goals are to collaborate with experts to create our courses and really update and improve them over time, because we know that these technologies are changing all the time. And also, we can always make the material better for individuals to have better access. And, to create these tools to help others with their content to reach wider audiences. And so we really wanted our material to reach the widest audience possible. And we wanted to create a way for others to do the same. And we wanted to make it super easily updatable. And also for others with their content. So we ended up creating some software called Otter, or open source tools for training resources. And basically the idea behind this is that you can write material one time and then publish it in 3 different forms. One is just a simple book down based website on GitHub, but also LeanPub and Coursera. LeanPub allows you to have a certification of completion, but you can do that for free. Whereas Coursera, you have to have a membership, but we know that there's lots of students on Coursera, so we wanted to provide access. And so this is mostly done through GitHub Actions, Docker, doing things in our Markdown for the most part, some R packages, and our website has some guidance on the documentation on how to do this. But really it comes down to our template, which you can find through our website, but it's on GitHub, and you just use the template with the use template button, if you're familiar with GitHub templates. And it really relies on pull requests. So we know that that's challenging for some users, and we're trying to figure out ways to make that easier. But it's because it uses a lot of GitHub Actions, and it creates previews of the course as you update it. It also allows you to choose whether you want to check spelling, style of the code, check URLs, see if they're broken, check quiz formatting. LeanPub is very difficult to format quizzes for, so it checks all that, checks all the rendering. And if you were to do the normal process of this, it's extremely slow. We have done it a lot. We needed to automate it. We finally did. And it's just so much better. So I highly recommend it if you're interested in anything like that. Honestly, it's useful for other things. We've created other offshoots of this for websites and various other projects. And so through this initiative, we've created several classes. So there's one about leadership for cancer informatics research. We all say cancer because we're focused on that, but really they're all broadly applicable to informatics. So this first class is sort of looking at ways in which we can manage research labs to be better at collaborating in multidisciplinary projects, and also promoting more diversity in our workforce and also in our research. Computing for cancer informatics describes a bunch of resources for computing and also fundamentals about how computers and computing systems like servers work. Documentation and usability is for software developers in terms of how can they write the best documentation and how can they make their tools more usable. And then we have a couple of courses about reproducibility. The first one's really geared at those who are complete novices. So just like generally getting familiar with version control, what it is, whereas the second course actually goes into it. And then these other courses, 6 through 9, are almost in development and coming soon. One about ethical data handling, how to choose between all the broad genomics tools that are out there with some fundamental information about the various data types. Scientific software development beyond coding, as well as overleaf and LaTeX or LaTeX for scientific articles. We also have some proposed courses for cancer imaging, clinical informatics, data visualization, machine learning, and dissemination and engagement for scientific software. So stay tuned if any of those are interesting to you. So we're always looking for additional expert reviewers. So if you'd like to check out our courses and contribute, please take a look. Or if you'd like to take our courses, also interested in having more learners. We're going to do more hands-on workshops with surveys and plan to do analyses based on that and our Google Analytics for our courses that are online. And we're always trying to think of new ways to increase access and awareness of the ITCR tools. So we're creating some tools related to that, how to, prepare tool users and make tools more accessible. And with that, I'd just like to thank all the funding sources, all the CBOs that helped with the project, and all of our learners and my collaborators. And that's it. Again, you can find the slides at my website.
Thank you, Carrie.
Thanks.
All right, any questions? Maybe I'll ask a question. Oh, Mark was there.
I have a question. I have a quick question. Anyways, this is super cool. Thanks for talking about it. And are you able to share the slides? I feel there's so much information that I want to go check out after the fact. So I don't know if you're comfortable sharing the slides.
Yeah, they're at my website. So I'm gonna I'll put that in the chat.
Great. And so the one question I had is for the case studies, the open case studies, which is really nice. I think for all this teaching, it's a really nice concept. And so is there any thought, and I think you alluded to it a tiny bit, is there any thought that there could be some crowdsourcing here to go into perhaps analyses that are beyond maybe, I'm just thinking doing causal inference analysis, sort of illustrating causal techniques in the context of some of these examples. And if I were to do that, it would make sense for others to benefit from it as well. So is there a mechanism for people to build on top of this and then sort of feed it back to, the hub, which is you guys, in order to, and I'm not sure exactly what the quality control would be, if people start to do that. So is this something that has happened or that you envision happening?
Yeah, so it is something that we've been thinking about. We haven't had a lot of takers. We have one person that I need to contact who is working on a Python machine learning based case study. But yeah, a causal inference case study would be amazing, and we'd be happy to collaborate with you. Indeed, it could get overwhelming because Stephanie and I, who are basically leading the case study project, we don't have funding for it anymore, and we're just kind of maintaining them out of love, and so we don't have a lot of time. So we kind of set up a system where it's in the guide that's on our website for that, that explains how we want people to engage in that way, at least from having not tried it yet, but our theory of how it could work. And so we have an automated issue system on GitHub where you can submit an idea and we can work with you. And we thought that we might limit it to, a couple a year or something that we could actually vet and have it go through our review process if we wanted it to be officially part of the case study archive. And then we also had the idea that people could just post as a community other case studies that maybe weren't vetted. So that's the idea for that project. And then if for interest in ITN, we're also open to other collaborators on that, but mostly work with those who are funded by ITCR.
You say so there seems to be there is a formal pipeline with instructions that I need to go and check out in the guide, but also perhaps something a bit less formal where it's a forum and people can post their stuff.
Yeah.
And it hasn't been vetted yet in some sense, but others, use it at your own risk
Right.
until perhaps it does get vetted and makes it into the formal sort of repository, perhaps. Does that make sense? Is that what you mean?
Yes, exactly.
I see. Super cool. Really, really cool. Thanks for sharing that. I'll be looking into it, so I might reach out.
Yeah, and feel free to email me directly too.
Great. Thanks so much.
Thanks.
Right, any other questions? So yeah, maybe I'll ask a question. So it feels like, high school will be the right time to introduce students to a lot of tools. I feel like data visualization, for instance, and students just might not be aware of it. And so have you found any effective way to reach out to high schools and get students exposed to some of these concepts and tools?
Yeah, that's a great question. So on our survey for our open case studies, we were curious who was engaging with our resources and potentially using them in different contexts. And we do see that there are some high school instructors and even middle school instructors that are looking into them. So that's exciting. But at Fred Hutch, there's several initiatives to work with local high school students and as well as students in some other states like New Mexico to engage them in cancer research or data science. And so we're working on some new projects to try to do that, and very exciting.
Yeah. Any other questions? If not, then let's thank Carrie again. Thank you, Carrie. Being on our problem.
Thanks, it was great.
And I'll see everyone next week. Bye.
Bye, thank you.